Hey folks, I wanted to give you a hand in understanding this last section in the chapter on normal distributions. So far, the reason why you see this picture in front of you is this is the last thing that you and I did together. We worked on figuring out what the percents were of the red shaded area for this problem, this problem, this problem, and this problem. And what we did is we either used the z-score to find the percent, or and we did that with z-tables, or we had an x value and we used the x value to get a z-score, and then we used that z-score to find the percent using the z-tables. Okay, now today we're going to go and we're going to flip things around and do things in the opposite direction. Today you're going to be given a percent and you're going to have to figure out what the z-score is, or the x value associated with the z-score. So let's take a look and see what I mean. In the online textbook on page 130, they begin to talk about how to get from percentiles to z-scores. In other words, how to do things in reverse. This is also known as inverse normal. Anyways, basically what will happen is we'll be given a question like what z-score cuts off the top 10% in a normal model, and then we'll have to go to our z-table. This is it down here, and we'll have to look for where we have the top 10%. In this particular example, they're making us think because in order to get the top 10% in a z-table, we have to look at the bottom 90%. You may recall that all of our z-tables, let me remind you. In a z-table, with the percents that are in the table, by the way, this middle part is where the percents are. On the left or right side is where you have the z-scores. And if you need one more decimal of accuracy of z-score, that's why we use the columns. Anyways, every time we use a z-table, whatever z-score we have, we're looking at the percent to the left of it. So, when we want to go the other direction, if we want to take a given percent and find a z-score, then we have to look at the percent that is to the left of a given z-score. So in this particular case, this particular z-table will not be useful to us because these z-scores are all negative. We were asked to find out, let's see here, what were we asked? We were asked to find what z-score cuts off the top 10%. So in order to do that, we got to go down and use this other z-table. By the way, I found this by Googling and went to z-table.com. Anyways, when we go to this table, we can see, okay, well, here's percents with z-scores that are positive, and we're looking for the top 10%. Well, the problem is that if I go and look in this table, 10% is nowhere in this table. It goes from 0.5 all the way to 0.9998. So we're not going to find 10%. What we can find, though, is 90%, and whatever the 90% mark is, the z-score for 90% below the z-score will be the same as the z-score for 10% above. So I'm going to try to re-say that. The z-score for 90% below is the same as the z-score for 10% above. So in this case, we're looking for 90% in the table, and that'll get us this z-score, and that'll be the same z-score as the one that we need for the score that cuts off the top 10%. So if we go and look, we will find, let's see here, 0.9, 0.89, here we go, 0.8997 and 0.9015. Now, I got to admit that there's a little bit of a fine art to picking which one of those values you like best. It's not too bad, though. I mean, basically, you just want to find the one that's closest to 90%. And in this case, if you want to figure out how to do that, you can subtract, do 0.9 minus this, and then do 0.9 minus this, and whichever one has the absolute bigger number, that's the one that you don't want. You want the the difference that's the smallest. So in this case, if we do 0.9 minus 0.8997, we'll get a smaller number than if we do 0.9 minus 0.9015. So it's going to be 0.8997 that we are looking for. This will be approximately the 90% mark in our z-table, and that will get us the top 10% as well. So let's see here. So then if we like 0.8997, the z-score associated with that is 1.2 and 8. So 1.28. So 1.28 should be the z-score. And let's take a look. Let's see if they agree. Oh, they agree. They looked up 0.8997 just like I did, and then 1.2 and added the 8, and that got us z of 1.28. Now, if you don't, I'll leave it at that for now. I would say reading through this example in the book yourself would not be a terrible idea. And then let's see, do they have anything else good in here that can help us out? I think that's it, other than they've got some practice problems for us to do. Okay, so I want to show you a little bit more, but I at least wanted to show you one problem. Let's take a look at a couple more problems where the percent, well, let's take a look at least one more problem where the percent is between two values. I'm going to try to walk you through these few quick examples, 9A, B, C, and D. And of course, they're in your textbook, so you can, later on, you can go back and look at, this is page 131, and you can try these yourself and see if you remember what I told you earlier, like right now in the video. So anyways, let's go through this real quick. So let's say we wanted to find the z-score associated with the lowest 40% of the distribution. Let's take a look at the table. So lowest 40%. Well, the good news is, since it's the lowest 40%, the percent we look for in the z-table is 40% because it's below the z-score of interest. If I look at the top z-table, I can see that goes up to 0.46. So it must be in here somewhere. I'm looking at, oh, you know what? I want you to pause the video and try to get the answer yourself, and then I'll tell you in a sec. Okay, hopefully you paused it. I'm thinking that the z-score will be somewhere between, here we go, somewhere between 0.3974 and 0.4013. Okay, so let's see here. So which one's closer though? This is about 0.0026 away from 0.4. This is about 0.0013 away. So I'm going to say this is going to be the closest one, 0.4013. And that z-score will be negative 0.2. And then whatever this column is. So let's scroll up, and that looks like that is the 0.05 column. So negative 0.25 is what I'm thinking for, for this problem that we're looking at. So the answer for A, the z-score should be negative 0.25, I believe. You should check and double check my work and see if that worked out properly. Let's see, the highest 30%, I think we just looked at an example like that with the 10%. So let's take a look at the middle 30% and see, that's a little trickier. So the middle 30% is going to look like this. So I'm going to try to help you visualize the middle 30%. How do you find that? Remember that if we go, remember the 68, 95, 99.7 rule? Well, that rule will help to clue us in how we could find the middle 30% or 40 or 20 or whatever it is. Remember that if we go out in either direction from the mean, one standard deviation, we believe that we have 68% of all of our values in a normal model, all of our data. This is bigger than 30%. So 30% must be somewhere in between here. And I don't know whether it's really close to 0 or whether it's really close to 1. But I'm just going to go ahead and just make some cut marks just so that I have a visual idea of what I'm talking about. And then I'll go and I'll put some shading in here. Let's go ahead and shade the area that I'm interested in, the middle 30%. And then let's try to figure out what the z-scores are going to be. So We're not using the 68% anymore. I was just using that to show you that I have some idea of what the middle 68% looks like. Since this is the middle 30%, we must be going out 15% in either direction. I believe that's what we're looking for. We're looking for the middle 30%. So what that must mean is we must be going 15%. God, this is going to be hard to write. Sorry about that, guys. We're looking for the 15% that's here, and then we're looking for the 15% that's here, and we'd like to know what z-scores are associated with those two 15%. In other words, what will the value of this be for z, and what will the value of this be for z, okay? Obviously, there'll be somewhere, this will be somewhere between 0 and 1. This will be between 0 and -1. Now, I know that if I go all the way from the middle all the way to the left, that is going to be 50% of all my data. And so to get the percent that I need for this z-score, I just say, well, if I go all the way from the middle out, that's 50%. If I subtract this 15% off, in other words, if I do 50 minus 15, what's left over is 35%, and that's what all of this area should be. Now, I know that I want to find the percent in the middle, but in order to do that, I got to find the percent that's below that z-score. So anyways, so that percent, this percent over here will be 35%. And if I go and look that up in a z-table, I can find this z-score. In order to find the this next z-score, I'll have to take this 50% and add 15% onto it. So that'll be 50 plus 15 will get me 65%. And if I go and look that up in my z-table, I should find that the z-score, whatever 60. If I look up the 65%, remember, we'll be going to the middle of the table. Here's where the percents are, and wherever the 65% is, I'll find the corresponding z-score. And when I do, it will be the z-score for this right here. So there's a little bit of thought that's required in this one. We're told that it's the middle 30%, but we're really looking to find the z-scores. We got to find the percent that's below the lowest z-score and the percent that's below the biggest z-score. And when we do that, we can use the z-tables and we can get the answer. Okay, I am hopeful that this is a little bit helpful to you. I think I'm going to leave it at that.